So yeah, I'm intermediate between the two of you. I have papers that are just as technical as some as Peter's, but in a different field. But I've spent some time talking to policymakers.
Okay, hold your horses now, because we're live and I've got to introduce you. Just wait a second. Hi, I'm Metta Spencer. I'm in Toronto, and let's go today to Seattle and to the Washington, D.C. area. And let's talk about extinction, shall we? Now, listen, guys, if you are one of the climate change deniers, just go away. I don't want to fool with you today. Just go. We don't have time for you, because what we are going to talk about is going to be so scary that if you can't handle it, just go away, because this is important. There have been times on this planet when almost all life went extinct. We almost lost life on the planet several times. And some people think we're creating the conditions that lead to those same circumstances that brought about some of those extinctions. So today I am going to talk to what Paul Werbos calls the #1 most knowledgeable person about human extinction on the planet. And that is a man named Peter Ward. Peter Ward is a paleontologist, a professor at the University of Washington. He's in north of Seattle today. And he certainly knows a lot about the history of extinctions, and especially, I guess, the Permian extinction, which must have been the really close one. And in the Washington, D.C. area, we have Paul Werbos, who is a retired, I guess, mathematician by original background, but he's certainly a man of many parts and held important positions at the National Science Foundation, where he was in charge of picking whom to fund for research, which must have been a fun thing to do, but it also might have made a lot of enemies. I don't know if he didn't pick you. All right, so good morning, fellas, or good afternoon. Peter Ward, hello.
And hello back to you. And you were very close to where I did my postgraduate schooling. I went to McMaster in Hamilton.
I looked you up on Wikipedia, and they already told me you'd been at Hamilton, at McMaster. So, yep, that's a good place. I had a lot of friends there lately. Not so much anymore, but I've had a lot of friends there. So it's I would invite you back to your old stomping grounds. Okay, and Paul Werbos, hello.
Hello.
Okay, now, Peter, let's get going. I know this is a scary topic. It is, at least if we take seriously. I've read a couple of your books, and you got me. You put the fear of God in me about what might happen if we aren't careful. So give us the lowdown on what you think the conditions were that led to at least one, and I think you will say more than one of those extinction events, and whether or not we are recreating those conditions today on the planet.
And thank you so much for having us. It's hard to talk about scary things, and it's hard to talk about scary things in such a way that you can really suggest to people ways to make them less scary. It's easy to do a jump scare in a movie, you come out and big boo, but how do we go to solutions? Scaring can get people's attention, but scaring doesn't necessarily get people to look for solutions. And I think what we have to do in this world is really, there has to be, first of all, greater empowerment, that we need to have, especially empowering women in parts of the globe that I've been, where there has been very little schooling for women for religious or cultural or other reasons. But we all have to come together on this planet. We've just come through a plague, and at least we in the US are now showing some semblance, but that sort of community spirit of recognizing there's a problem has to be done about climate change. Because the past really, hopefully the past is not prologue. that the past has shown us that exactly the conditions we're seeing now, too much greenhouse gases, have or has led to mass death on multiple times in the deep past. So we really ignore the past at our own present peril.
All right. Okay, what are those conditions? What is it we have to worry about?
Well, one of the things about that you hear about the future, oh, the future, all the big movies about the giant storms and tornadoes and all the things, actually far more dangerous than superstorms of the future are a lack of storms. Far
Oh.
more dangerous is a case where the world doesn't have storms at all. In fact, it has no wind. And in fact, it really almost has no ocean currents. Think about a swamp. What are the conditions we think about? A swamp deep in a jungle, and you're down below the trees. There's not a breath of wind. The water is dead still and calm and quiet. And what comes out of those swamps? Bubbles. And if you get close to it, ooh, it stinks. Swamp gas. And where is that coming from? It's coming from rotting, vegetated material that has been buried and no longer is in contact with oxygen. And we have a whole series of bacteria that love to chew up organic material when there's no oxygen around. And a terrible gas called hydrogen sulfide burps out of swamps. Think of our
Is that
world.
what you call the swamp gas is hydrogen sulfide?
Yes, that's correct.
Uh-huh.
And it's H2S, hydrogen sulfide. There's also methane coming out of these places, a whole bunch of really nasty things.
Mhm.
So how could our world get to where it's no longer that small pond, let's say in the Amazon with a big tree cover over the head? What about every ocean is the equivalent on giant scale now of that swamp, where there is organic rotted material on the bottom. There's no oxygen in the water. Bacteria take over, and the bacteria, when they respire, instead of, as many bacteria do now, instead of plants do, plants take carbon dioxide and respire out oxygen. Many microbes respire out poisonous hydrogen sulfide.
Oh.
So how do we get to a world where the oceans are the swamp? And there's a simple way to do it. You simply have to warm the poles without at the same time keeping the tropics at the difference in temperature. What if we warm the poles and not the tropics? The polar regions get warmer, warmer, warmer. The tropics stay the same temperature. We no longer have really cold poles. And once we no longer have warm and cold, we no longer have high pressure cells, low pressure cells. We no longer have big winds. We stop ocean currents. We become a world swamp.
Oh my goodness. What an interesting idea. Now, one of the terms that Paul has used in referring to your work is not what I came across. So you're going to have to straighten me out. He uses the term stratified oceans. I'm not sure I read that in what you wrote, but I think that's what you're pointing at, that there's that the layers in the ocean have different components or something.
Yeah, let's think about what stratified means. I'm a geologist, and strata to us are layers of rock. And of course, the way layers of rock work, when you have a pile of strata or a pile of bricks, the oldest are on the bottom. But what about stratified society? I mean, economically now, what we're worried about is we have a very thin layer of the very wealthy sitting atop many thicker layers down below of the less wealthy. Well, let's pretend that stratified wealth in an ocean is where the oxygen is. And the wealthy are right at the surface, a very thin, wealthy, oxygen-rich place. Oh, and if you're an animal, I love oxygen. And then you drop down into deeper water and you find less and less and less oxygen. It's stratified from lots of oxygen to no oxygen. And once you get down to the bottom, if you're in a place where there's no oxygen at all, the types of microbes that are living there, because it once was an oxygenated ocean, the types of microbes change. We start getting these hydrogen sulfide producers. And the stratified oceans are the first step to leading to a major mass extinction.
Okay, now you're talking about stinky, swampy ocean, but the stinky swamp is, if if I'm understanding you, is at the bottom, not at the top.
It is. The sticky stuff's on the bottom. And even in our swamp in the Amazon, what we have is a lot of oxygen in the air around it. But when you're talking about a very, very, very deep ocean, you've got all that water. We have a model of what this looks like right now. It's called the Black Sea. The Black Sea is an amazing place. You have at the top, because the water at the top is in contact with the atmosphere, there's a free exchange of oxygen from the atmosphere into the upper reaches of the water. But the Black Sea is a really current-free place. There's not a lot of water movement going on. And over eons of time, as you go deeper into the Black Sea, you run into water without, or very little, to the bottom, no oxygen. And down on the deep part of that, there's this nasty black mud. No animals can live there. There's just not enough oxygen for animals to survive. Only microbes do. So what if the entire ocean was the Black Sea? And that's what happened in the Permian. It's what happened at the end of the Triassic. It's what happened in the Devonian. It's what happened in the Ordovician. It's what happened at the end of the Paleocene. Over and over in deep time, we've had these conditions. And why do we get these conditions? How do we get to this place? Because, as Paul is going to point out, stratified oceans are going to be a consequence if we slow down ocean currents. If we make what we have a very special current called the thermohaline circulation system, which simply means it's like an escalator. There is an ocean current now that takes oxygenated water. It's like the steps of an escalator and escalates it all the way down to the bottom. The deep oceans today have as much oxygen as the surface in most places because there are not the usual currents we think of on the surface. These are vertical currents. Escalators go up and go down. So we have escalator currents that take water that has a lot of oxygen or very little oxygen and moves it around. It keeps the deep oceans, what we call ventilated, full of oxygen. If we turn off the escalator, we start the process that leads to mass extinction.
Now, this then you would attribute to global warming, because now I haven't thought about it this way, but what you're saying is that the poles get warmer and the equator doesn't, or doesn't much?
Not much. And that the reason Paul could explain it because he's a way better mathematician than I am.
Well, yeah, I looked at it. When I heard Peter's talk on mass extinctions, that was a life-changing event for me. I didn't think climate change was so important at the start of 2009 when all the climate legislation was coming. And I even worked on the committee that was developing those bits of legislation. And then I came back to NSF for a talk by Peter Ward. And the director of geosciences at NSF said, I want to introduce you to the world's #1 expert on what really happened with these mass extinctions. His talk was a life-changing event for me because then I realized, oh my God, I don't know whether it's going to happen again or whether it's not going to happen, but I'm not here to form an opinion. I'm here to find out. So I studied Peter's book. I'm very glad I did. Studied it in detail. And these thermohaline currents are really the core of it. If we get to stratified ocean, probably that will kill us. We need to check this. We need more science to verify the exact details of Peter's story because the details are important. The details are the variables that decide whether we live or die. So we better get this story straight. We need research there, but then we need to find out where are we on stratified ocean. And I've looked into this stratified ocean issue. It turns out the oxygen that keeps us alive, the most important oxygen is the oxygen that goes to the bottom of the Pacific Ocean and protects us from these bad bugs. And the oxygen that gets to the bottom of the Pacific Ocean, the deep bottom currents, come from a very small part of the Earth. At the edges of the South Pole, at the edges of the Antarctic, are some special little places called Polynesias. And we've studied these. There are currents that bring the oxygen in these small little places to the bottom. I even took a cruise once to that neighborhood. And people were saying, oh, look at those silly penguins. laughing. Well, they should laugh at us because those little beaches where they're sitting are where our oxygen supply is. And what we're doing to where these penguins are standing, if we don't stop what we're doing, we're in trouble. So it's not the global warming, it's the warming specifically to these parts of the Antarctic. And there are other things that we're doing that we need to understand. We do know that in the last 10, 20 years, the best data from NOAA show a reduction in the deep water Antarctic. But that's only a few years data. We need to get more data. We need to understand the process better. We don't know. It could be better or worse. The best data I've seen say we're 30 years from running out of oxygen.
No, you refer to oxygen, but if it's there's oxygen in CO2, but does that count as good or bad?
No, not in CO2. We're talking about good old fashioned O2.
Yeah, okay. Now here's what straighten me out, because there's another story that I don't understand how it fits what you've just described. There are people who are concerned about global warming whose solution or proposal is this, that you sprinkle iron filings in the ocean, especially in the deep parts of the ocean, and this will create a phytoplankton bloom. And the phytoplankton will absorb CO2, as all good things, green things tend to do. And then it will sink to the bottom of the ocean. And this is supposed to be good because it's going to take CO2 out of the atmosphere for us. And we're worried about CO2. Now, suppose you have these two stories happening. You've got to worry about getting oxygen to the bottom of the ocean, where the other story is you're taking CO2 to the bottom of the ocean. Straighten me out. How do these two theories connect together?
You know, it's funny because my wife asked me almost exactly the same question this morning. I have learned to be in awe of her ability to anticipate all kinds of things. But the fact is, there are three levels of what we're discussing here. The first level is the group where Peter is one of the world's 4 leading authorities, which is how do we know the conditions that could lead to the H2S emission and kill us all? And we know it's stratified ocean and fertilizer in the ocean, but these guys have a lot more to say about the exact conditions. We need to know how far we are. But the second issue is, how close are we to stratified ocean? That's another big topic we got to work on and understand better. But the third topic is, what do we do about it? And that's the area I worked in at the National Science Foundation. Mm-hmm. Okay, I was in the technology division at the NSF, the technology directorate, really, engineering directorate. And we were working hard on technologies that could help. But the problem is, which technology helps? We don't know which technology will solve the problem if we don't know what the problem is.
Don't get ahead of me. I want to know how these two.
Oh, but I'm not getting ahead. Because what you're talking about is geoengineering. And so I have a little website where I say there are 5 things we got to do on climate. Number 1, understand the problem. And then 4 ways to solve it. One of them is geoengineering. And she's part of the geoengineering movement. There are many approaches to geoengineering. There are many approaches to keeping us alive if we're on a bad course. And I certainly agree with her. We need to put effort into keeping us alive. The woman you were mentioning with the iron filings?
No, it's not a woman, it's a guy, but never mind. Okay, go on.
My wife cited a woman doing it. So there are men and women who are interested in geoengineering. Geoengineering is one of the areas we need to work on, but we have to be careful how we do it, because some ideas for geoengineering could make the problem worse.
Yes,
that's
indeed.
The bottom line.
I want to hear what Peter thinks will, how these two stories, if you had both of them going on at once, what would be the result? 2 things. You're trying to, now one of the things that I don't know why I understood you, but you talk about fertilizer. You haven't mentioned it so far. Paul just did, but you talk about fertilizer because that's going to create feed the bacteria. Is that it? Tell me about that part of the story first.
Is that me or Paul?
You.
Well, we are certainly worried an awful lot about phosphates and nitrates. All plants need phosphates and nitrates. That's what fertilizers are. And runoff coming from the land goes into the ocean, and you get more and more phytoplankton, more life. Well, that's good. Phytoplankton make oxygen. That's good. Except then, because we've killed off so many tiny fish, we have pulled off so many herring and sardines and this and that, in many places around the world, these beautiful blooming phytoplankton all really exploding in numbers larger than ever previous because of all the farmers' fertilizer. They sink to the bottom, down to that same darn bottom again, and they go to the bottom as they rot. They suck up all the oxygen that is already there and start removing oxygen from the bottom. So you combine fertilizer to the bottom that's in the little bodies of these tiny little plankton, as well as these currents slowing down, and we have this double whammy. Now, going back to your idea about the iron filings, one of the things you have to think about in any geoengineering, which Paul well knows, is that what is the cost? How much remediation does it do to put the iron filings in? And it does do things. You're right. It could be a very effective thing. But how much carbon dioxide do you put in the atmosphere when you mine the iron, when you grind the iron down into little particles, when you take the ships that have to drop it or the airplanes that have to drop it? They're all putting carbon back into the atmosphere. I was seeing yesterday, I got two very depressing reports from a very close friend of mine named Nate Hagens, and I really recommend you get him on your podcast. He's one of the great thinkers. He's keeping track of carbon dioxide up into the atmosphere and carbon dioxide down into plants or into the rock record. And right now, the Amazon rainforest is putting more carbon dioxide into the atmosphere than it's taking out. And British Columbia right now is an enormous producer of carbon dioxide from its forests because they're burning. When you burn forests, you've taken all that carbon dioxide stored in living material and liberated it up into the sky. These forests are human-made forests, and the CO2 that they're producing is human caused because so many of these fires are preventable. So geoengineering, as Paul is very correct, geoengineering has to be looked at in terms of what is the benefit, how much CO2 does it remove from the atmosphere, but how much carbon dioxide did it take? You know, a friend of mine gave me a great analogy. I was driving around a gas guzzling car. I said, oh, I'm going to replace it with an electric car. And they said, okay, let's think about this. What is the equation in terms of just CO2 for you replacing that car? You're going to buy a new car. How much energy, how much CO2 was liberated in the production of that car? Secondly, your car is still driving around. You replaced your car with two cars. And now you have also all the CO2 that had to be liberated because you bought a new car. In fact, if you kept your old car, even though it gets fewer miles per gallon, you're doing the earth a greater favor. We have to think about this. We have to think about
actually. I edit Peace Magazine, and we now have a feature every time called Current Controversies. And one of my friends in New Zealand is in charge of telling me about controversies in her social network. And her family is divided on the very question whether to buy a new electric car or use up their old gas guzzling car. Okay.
It's the way we have to work. And there are just so many of these little controversies in life.
Right, but now let's assume that you could get this iron for free. I mean, without any CO2 costs. Now you put this iron in and it does make blooms of phytoplankton, the same as the phosphate from the fertilizer runoff from the ocean, from the rivers downstream and into the Gulf of Mexico, et cetera. So both of these are doing the same thing, right? They're creating a phytoplankton bloom. Now, one of my friends would say, hooray, hooray, because those phytoplankton are going to be sucking CO2 out of the atmosphere. They will then die and they'll take it to the bottom of the ocean. Good. Now we've sequestered some CO2. That's what we want to do. Aren't we doing great? But what I hear you saying is when it gets to the bottom of the ocean, it's going to rot and it's going to suck all the the oxygen, use all the oxygen that's there and make it even worse than if we hadn't done it. So is that what you're saying? That it's the net effect would be deleterious?
Yes, and we have a case where this is the point happening right now off the coast of Namibia, which is southern Africa. The west coast of southernmost Africa has one of the most productive areas. You would think Africa, it's really, really warm water. It's not. Currents, cold currents from Antarctica come right up the west coast of Africa. One of the really important aspects of the whole controversy is that cold water holds more oxygen than warm water. Cold water is what the escalator, the thermohaline, carries down to the deep ocean. That's what carries the oxygen, cold water. When water gets warm, it releases its oxygen. So when an ocean gets warmer and warmer, there's less and less oxygen in it. Off the west coast of South Africa, the fisheries have killed almost all the tiny fish, which ate these very productive upwelling blooms of phytoplankton. They sink to the bottom and they are now emitting hydrogen sulfide. And in fact, there's a coastline in Namibia called the Skeleton Coast, where you walk along the beach. It's almost always shrouded in fog because you've got really cold water right next to really hot landmass. And the Skeleton Coast smells like rotten eggs because hydrogen sulfide is now coming out of the stratified ocean right next to the coast of Africa and just coming up on that beach, Rotten Egg Beach, and it's really not a happy thing.
So the
Okay, so
H2S
that's
has
what's gonna
already
kill it.
started outgassing.
Yes.
Oh my God.
Oh, yes.
So this is what's going to kill us, is the hydrogen sulfide, which is apparently extremely poisonous.
Yeah, and it doesn't have to kill us. We humans could go forward for the rest of our lives with face masks on.
Well, yes, but I mean, if the Permian extinction occurred because of hydrogen sulfide, then it's not just face masks. It's going to be trees and everything else, birds and all get killed by the.
Absolutely,
So
absolutely.
we aren't going to survive if we don't have all the other critters around us.
And that's the truth.
Uh-huh. All right. Now, how do we figure out how quickly this kind of thing might happen? Not only that, but if you take that option away, seeding the ocean with iron and hoping for phytoplankton, you're going to say, no, we hope to get rid, not to have phytoplankton, right? We don't want to have the fertilizers or the iron there. Okay, then how else? That's a different question. That's come later. But what else is left for us to remove the surplus CO2 from the atmosphere that exists now? We can't just, because I mean, yeah, we can stop emitting greenhouse gases, and eventually, I suppose, things will go back to normal. But it's, in the meantime, the temperature, we can't keep the temperature down to a reasonable amount unless we actually do some negative emissions, that is, removing stuff from the atmosphere, CO2 and other carbons from the atmosphere. How are we going to do that? But that's question number two. Question number one is, how quick are we getting to this catastrophe?
Boy, that's the $64 trillion question. We are trying to understand, as Paul has pointed out, the way you can understand if stratified oceans are forming is simply by measuring the rates of these currents themselves. So one really good way to look at this is to look and see if, for instance, one of the most famous of these thermohaline currents is the one we see on the surface in the Atlantic, the Gulf Stream. The Gulf Stream brings warm water up from the tropics, and then it keeps moving north and then jumps across the Atlantic. But as it moves north across the Atlantic, it gets in a colder and colder air. And as the water gets colder, it picks up oxygen until it hits almost Europe. And now it has so much oxygen and it's so cold, it's really dense, so it sinks. It's this downward conveyor belt is from high density, cold, oxygen rich water, which falls all the way down to the bottom of the South Atlantic and then moves, or I'm sorry, North Atlantic, and then moves southward. And so creeps across the bottom full of oxygen and delivers oxygen to that sea bottom. Now you said phytoplankton bad. Well, we need phytoplankton, but we also need the balance. We need the small fish, which eat the phytoplankton as well. The phytoplankton is producing oxygen for us. We absolutely need that too. So one of the really, it's such a holistic aspect. We need to really bring our fisheries that are now out of control back into control. Who would ever imagine that the great Newfoundland cods, the cod fishery would crash as it has? Who could imagine such a thing? When you look at the records, the centuries that humans have been essentially mining. And that's what a close friend of mine said. That's what fisheries is. Fisheries isn't a sustainable resource like growing cows. Fisheries in most cases is mining. And what mining does, mining takes, mining never gives back. We've mined the fish away from the surface of the oceans. They are not growing back at any rate that is sustainable. We have to think of fishing as mining. What we have to do is reduce the fisheries of the world.
Well, could it be, is there a way of fishing that replenishes the fish stock? Is it always inevitably just mining, or is it possible that we could nurture new habitats for fish where they don't live now?
Well, we certainly have to stop eating deep water fish, because deep water fish grow very slowly. They have very low reproductive rates. I grew up in the Inland Sea between Vancouver Island and Seattle, the Salish Sea, we call it. And as a boy, we would go out to the Gulf Islands, these gorgeous, beautiful places, and catch what they called copper rockfish. Beautiful spiny fish. It's probably about, it's 1.5 feet long. The biggest ones, maybe a foot, big, fat. We'd take them back and we'd skin them and fillet them and cook them on open fires. A few years ago, it became known that the copper rockfish we were catching were at least a century old, and some older than that. We've just discovered that the great big sea urchins at the bottom of the Salish Sea, 100 meters deep, are 500 years old. These creatures down at those depths, once they reach a certain size, very little kills them. We have to stop eating those kinds of fish. There are many sustainable, smaller fish that you can not mine, but actually take care of. But fisheries management is a joke. There isn't management. They're simply watching the mining of a finite resource disappear from the face of the earth.
Okay, well, there are such things as fish farms, which have a very bad reputation for breeding diseases and things like that. But could that be done on a big enough scale? I mean, I have to think not only of global warming, but of the growing population. We're going to have maybe 10 billion people. They've got to eat. So can we farm fish, and would that help solve the problem of keeping enough fish in the ocean to maintain the relationship with the plankton, et cetera?
Well, the fish farming I see going on now is certainly not going to be very sustainable. The Atlantic salmon is what we see in the stores around here. But even now it's costing over $10 or $11 a pound for farm fish. That's not going to feed very many people outside of the rich industrialized countries. Farming great big carnivorous fish is the wrong way to go. What you want to farm are the small sardine-sized fish. They grow fast. They have high reproduction rates. We just stay away from it. But why go there at all? There are so many plant-based alternatives.
And it's really important, because this begins to get to the technology solutions aspect. And that's kind of like where I used to work, right? And in addition to understanding the problem, in addition to developing and understanding geoengineering options, there are 3 areas where we could be interacting much better with the climate. And one of them is agriculture and fisheries and related. Those sectors could be helping us with the climate change, but right now they're hurting us. And whether they help us or hurt us depends on how intelligent the policy is. And that depends on how much rationality and science goes into making policy for agriculture and fisheries. They could be a great help, but right now they're hurting us, and we need better information. We need like science to figure out how to do it right and not screw it up. There's
Well,
no
I
doubt.
agree to that, but I've been trying to figure out how much different sectors contribute to global warming, and agriculture. Apparently, we could reduce maybe 25% of our problem with good agriculture and good farming, but it's not going to solve the whole problem. I was thinking, okay, let's use the oceans too, but well, you've got me scared about the oceans. It sounds like everything we're going to do can only be counterproductive in the ocean.
We can do good things and we can do bad things. So if you leave aside geoengineering, there are three sectors where we could have a big impact that are about equal. There are three critical sectors about equal. One of them is generating electricity. One of them is transportation. One of them is agriculture and related. I used to think it was smaller, but it turns out it can help or it can hurt. The difference between plus 25% and minus 25%, it's just as important as electricity, getting it right instead of getting it wrong. It could help us or it can hurt us. Getting it right in agriculture, which includes fishing and farming, is one of the big three of the normal good climate policies.
Mm-hmm. Okay, all right. Peter?
Look, this is a nice moment, Meta, because when we have these discussions, I always get to this point and I see that hand on your face, and it's kind of like, oh my gosh, it's so complicated and there's so many huge problems. This is where an awful lot of people then just turn away and say, well, we can never fix it. So I'm going to move on and think of something else. But we can't afford to do that. I mean, there's no single solution to anything. Paul's right. This is coming from many different directions, but we certainly have to stop. Do you know what just broke my heart, Meta? I love Australia. And I actually moved there to forever in 2014 and had a job at the University of Adelaide, where I would still be now, but that I couldn't get my sons into Australia. So I moved back to be with my family, of course. Australia just came out as the worst of industrialized countries for cutting down on emissions. That's such an ecologically friendly place. The Australians I knew, they were green. They really considered this, and yet their government continues to be one of the #1 coal exporters and coal burners. There's such a huge disconnect between the average person like us and the governments which are running these policies. There has to be a move away from fossil fuels. I mean, everything goes back to that. We just have to get away from burning coal and oil. And when you see people fighting wind farms because they're ugly, or the complete idiot who's our last president, asterisk, of the United States, saying that wind farms will cause cancer from the noise, that's the insanity of people who are fighting against these. We have to use alternative energy sources. What you're talking about, mitigating CO2, much of that won't be necessary if we get off coal and we get off oil. You're talking about what causes the CO2. Well, the greatest causes of CO2 really are turning out to be so much power plant production. China keeps building brand new coal-fired power plants. People with population increasing want electricity. With that, we have to burn more fossil fuel as we are doing business today. So to me, it is simply getting away. I hate to say this, an advanced, brand new, better type of nuclear energy seems a better solution than what we're seeing today from coal-fired plants. But better than all that together is going to be good.
I just did a show yesterday with a guy who had been the head of the Nuclear Regulatory Commission, and he's not in favor of nuclear. So
well,
there you go.
I mean, I live close to Hanford. There's still no solution for the waste, but we are really looking increasingly at a triage position.
Well,
Yeah,
okay,
yeah,
I don't think we are going to talk about fossil fuels today because I talk about fossil fuels about twice a week as a rule. So I have just tons of conversations about uh, global warming, and I'm exaggerating. It's not twice a week, but it's pretty close. And so we have these conversations about fossil fuels. What I am scared about are two things. I already a couple of months ago got really scared by a guy named Peter Wadhams, who's concerned about the emissions of methane from the bottom of the Arctic Ocean. That he's now worried about the, an extinction event, so to speak, from that source. Now here I've come across your work, which tells me we have to worry about hydrogen sulfide, because that's going to be what gets us. So between methane and hydrogen sulfide, what else have we got? I want to know what we can do to prevent this hydrogen sulfide problem. That's where I'm stuck now, because that's today we've got to focus on hydrogen sulfide, which I don't know the first thing about, except that apparently it stinks.
It does. And the interesting thing about it is we've evolved such an efficient mechanism of knowing it's around. So hydrogen sulfide at about 400 parts per million will kill you. But we can detect several parts per million, because go ahead, I'm going to get to the indelicate part of the talk today. Let's go out and have a gigantic Mexican lunch with refried beans and more refried beans, and really throw in the refried beans, and then we have chili with it. Oh, and chili without meat, beautiful, more refried beans and more refried beans. And of course, when those legumes get into our intestine, we start digesting this stuff. But one process of that digestion is the production of hydrogen sulfide, which comes out of us as, here's the word, flatulence. See, I used the $3.
Yeah, but I hear about that all the time, but I hear it not described in terms of hydrogen sulfide, but rather in terms of methane, because that's what, if you'll excuse the expression, farts are.
It's also the hydrogen sulfide. And when we are using our nose, when we smell that, we can detect such tiny little levels because it's so dangerous to us. And we know, interestingly enough, we mammals are way more susceptible to hydrogen sulfide than our reptiles and cold-blooded.
Really?
Oh, yeah. So that's another evolutionary aspect.
Apparently it's both methane then and hydrogen sulfide. Do they tend to go together?
Oh, yes. Well, it's all the digestive process within us. It's dealing with anoxic oxidation and reduction. So when we're doing these digestive mechanisms and parts where there's very little oxygen involved, there's this production of this stuff because we have gut bacteria, which many, many different kinds in there. And when we get these beans, we produce more methane and hydrogen sulfide. The fact that we can smell it tells us how important it was evolutionarily to stay away from this stuff. The fact we don't like that smell, that's saying that's not nice. There's something bad about this. Evolution doesn't mess around.
There are some partial solutions to the cow flatulence and maybe other things too. I never heard of people eating it, but apparently feeding seaweed, a certain kind of seaweed, to cows reduces very much the production of the methane that they emit from both ends. And so now that I've heard that raising kelp in the ocean is a good way to absorb CO2 because it's a plant. Would that be a good thing? We should start raising lots and lots of kelp and take it out and feed it to the cows?
Well, the problem with raising lots and lots of kelp is that when you start doing that, you are starting to change the ecosystems of the coastal oceans again. There was the case in California where, of course, they killed off the otters. Once the otters were gone, the sea urchins multiplied by many, many times. The sea urchins began eating all the kelp, and all the kelp disappeared, and that ecosystem all fell apart. I think in this particular case, that may be a solution and may not be a solution. But one of the topics you mentioned early on that I think really is relevant that we haven't really explored is, could we go back to the Permian extinction and try to tie all this together? Because that extinction and how it came about really does bring almost everything we've talked about today into a nice little neat, very scary package.
Okay.
So how did we get a Permian extinction? We didn't have humans, so we didn't have power plants. We didn't have anybody making all the methane, and we didn't have us with cars. We didn't have all this stuff. So why is it even relevant? I mean, how could it have anything to say about the present? And I asked students, how could we, what's the one solution we could do to stop climate change and global warming and all the CO2 rise? And there's a very simple solution. If only we could manufacture great big lids and cover every volcano on the planet with a nice little tight lid, and they couldn't emit any more gas, we'd be in great shape. Of course,
No, really. But I thought that was the theory that has been discredited. When I was studying or reading about Permian extinctions, the answer was that it always was caused by volcanoes in Siberia. And so when I came across your notion of phytoplankton or something in the ocean, I thought, well, that's a different theory. This hydrogen sulfide is different.
It's the same theory. It's
It
exactly the same. Yeah, we get a Permian extinction when we warm the poles to such a warm extent that ocean currents stop and we get a stratified ocean. Permian extinction is the death mechanism is the hydrogen sulfide. But getting to it, you need all those volcanoes. That was how we got this world that we never want to get back to, where it is so warm at the poles that there's no temperature difference, or very little, between the South Pole and the equator.
Yeah, so it's important that people are clear on the stages of causality.
Okay, please.
So the H2S caused the mass death. Stratified ocean and fertilized ocean caused the H2S production, as we now start to understand as a result of new work. But then how did we get to stratified ocean? And in the past, we had things like volcanoes creating emissions, which got us to stratified ocean. But there are other ways to get to stratified ocean. And the data show we are experiencing other ways to get to stratified ocean right now, like your example of Namibia.
Yeah, volvos, not volcanoes.
And if California and Chile become like Namibia,
Yes.
multiplied by 100, the H2S, we're going to see strange things in Mexico, in California first, but the whole world.
Yes, absolutely.
Okay, it's microbes that cause the H2S, right?
Yep.
Sulfonogenic archaea, I think. Is that?
Yeah, they're just nasty little things.
Nasty little bugs.
Those are single archaea or whatever they are. Those are the original single cell organisms before there were multiple cell organisms. Is that right?
And they're still around. Yep.
And they're still around. Yeah. Okay. But they were the first things.
Maybe. I mean, that's complicated. The first things were probably just little naked RNA strands, but for
Peter is author of the #1 book on the history of life on Earth, co-authored with Kirschvink. And that book goes into a lot of detail on what was the first life on Earth, and we're still debating it. We know it's been around for a few billion years, and we know that archaea came before the kind of life that we represent.
Yep.
Okay. It looks like we've got a big mess, and I'm glad that people are willing to be frightened, because I think if we deny things and try to say, oh, it's really okay, we're going to be all right, don't worry about it, we'll never get anywhere. But okay, I'm now in the state of panic, a suitable level of panic, but I don't quite know where to go from here. Yes, you want to push it back to fossil fuels. Well, yes, we're handling that, but you've got some other stuff going there, which I guess, the business of the stratified ocean and keeping the currents from going wrong and taking the and failing to take the oxygen to the bottom of the ocean. That's a separate, you can handle that as a distinct issue itself, right?
Well, it's the biggest issue. And to date, I've never heard of a single geoengineering solution to changing ocean currents on that magnitude. We're talking large scale Earth processes, and there's nothing that we know of right now that can fix that. Although people have been talking about it. Paul, I think you've heard about some of these solutions of how much melting of the glaciers up in the north causing fresh water to get in there is affecting these. And there's the whole sense of, we need to stop the ice from melting on so many different levels, yes. But Matt, going back to what are solutions, I think the two biggest thing any person can do is really, well, there's three things, but number one is what we eat, because how we, each person, when you're right, if we get up to 10 billion people, every single person, our eating habits are affecting the climate. Number two, what sort of transport do we do? I used to fly everywhere. It was with unbelievable horror when I realized that on a Kyoto protocol, my CO2 for a year would be used up, my allotment for a trip from Vancouver to Montreal and back on an airplane. Just sitting in that passenger seat, that one plane, that's me for the year. So it's what we eat, it's our transport, but it's also our politics.
Okay, there's a time element in here. How long it takes to have, if you change your habits, how long it's going to take. Now, it is simply a fact that if we stopped our emissions today, we would still continue heating and we would not be over it unless we do something more than simply stop emissions. So we have to remove CO2 or probably several different greenhouse gases from the atmosphere, certainly methane. We have to remove those as well as stopping emitting it. And so that's going to get us part of the way there. But if we did that, are we still sure that we won't have the stratified ocean issue come? Do we know that if we did all of these things, we stop emissions and we quickly remove somehow the excess green carbon from the atmosphere, are we on top of the ocean problem?
We need good news. You need some good news, especially if people are depressed.
All right.
Most of my job at NSF was to look at the new technologies which could change the game. And I have looked more closely at these options than anybody else, to be honest, because that was my job and I had lots of inputs. The technology does exist to solve these problems. The real problem, in my view, is the lack of good enough, useful, honest information connecting the real world, which includes people like Peter, also includes people on the farm and the fisheries, to the policy level. Right now, there is corruption and bias and filtering and 1,000 things getting in the way of climate policy. But if we had the right information in the right places, we could solve these problems inexpensively and make a profit, but we need the right information to get to the right place.
I'm sorry, but I agree with you. And I don't, because I think there's a lot of information out there that is not being able to be implemented. We know that unfortunately, the average voter is clueless and will not support a politician. What proportion of the voters of the US are still, not taking vaccines and denying climate change and all that? We've got some really serious problems about stupidity, human failings to give the kind of political support that is necessary to make democracy work. Democracy is no longer working precisely because we got too many idiots and we're all kind of not too smart ourselves. But the information, enough information, I would agree, is a lot of it is already accessible, but it's useless. Nobody can make it happen. They can't implement it.
There are people filtering the information from the point of reality to the point of policy. And we need to have some alternate pathways for information. And I want to thank you, Meta and Peter, because you are playing a critical role in giving us the nucleus of a new flow of information, which needs to be amplified.
Hope somebody will watch us.
I
That's
hope so
all.
too.
That's the
I'm
name of the game. Yeah.
about to say the same
Okay.
thing, Meta, is that you are obviously working really hard. You are doing this, it sounds like every day or weekly, you are just doing this. So something stimulated you to make this effort. I can imagine you would have a wholly different life if you weren't doing this, and yet you've taken it upon. There's a lot of people, there is hope. There are people, every time I go on a program like this with people such as you, I'm get way more hopeful.
Okay. Well, I must say this is just simply the most fun I've ever had. Because every day of the week I get to talk to guys like you or somebody like you. And I've never had so much pleasure as a social life in my whole almost 90 years. So, you know, I'm grateful to you, extremely grateful to both of you, because it is precisely my thrill and my challenge to try to figure out how to get this information that you possess into people's heads when they don't want it, you know, they don't want it. And, you know, so I'm all for, I'm love to be doing this. And here comes my assistant, Adam, no, has a question for somebody, I betcha, if you hold the horses. Adam, he's supposed to butt in and tell us if somebody has written a question into the chat box. And you're muted, Adam. So.
Oh, yeah, so we have quite a number of people who have been commenting on this discussion. One is that we have somebody who has joined us from Greenland, but the questions from Dr. Keith Henson asking, is it possible to genetically modify corn? And that there was a proposal a few years ago that genetically modifying corn could filter out all of the SO2 and H2S in the atmosphere. Is that a legitimate proposal?
Woo! Have you ever heard of that?
Let me take a quick crack at it. I'm hopeful. Yes, I think genetic modification and this technique called CRISPR, which I'm sure you've talked about on your show, are the miracles. But what has scared me biologically about any genetic modification is that genes are very slippery critters. Genes jump, genes escape. And so the modified corn is doing good news. Who's to say that gene doesn't jump into some weed and that makes that weed turn out to be way more productive than it was, then it grows out and destroys something else. So we have to be so careful with genetic modifications.
Yeah, and let me come back. If I were doing a US or a UN climate policy, I'd be putting money into these 5 big areas, and one of them is geoengineering. And the main thing we got to do with all these geoengineering things, we need a lot more research. We're not ready yet to massively deploy any of the forms of geoengineering which are out there today. Some are closer, some are further. We need massive RD&D, you know, really aggressive basic research to sort out what are the causes, what are the costs, what are the consequences, and what are the options. And certainly plant modification is one of the things that would fit in this geoengineering thrust, which we should be funding in a strategic way. Nobody's doing it yet.
Adam, do you have another question?
There's a few. So there's one from the viewer in Greenland who is in the process of typing it, so I can't see their full question yet. But then Keith Henson also would like to know, is there a possible benefit or whatnot from putting the iron filings on fishing ships and kind of distributing them when fishing ships go out rather than sending vessels themselves? And, oh, here we go. Sorry, the person from Greenland has finished typing their question. It's a question for Peter Ward. So Hans Joachim Schellhuber said he coined the term tipping point in the climate context, yet he won't go on the record to say that we passed the first tipping point or domino. what is Ward's comment to crossing the ice tipping point?
Say it again, if you will, Adam, because your connection is not
It
really
looks
good.
like part, yeah, it looks like part of the question might be missing, but they have a question for Peter Ward. So Hans Joachim Schellnhuber says he coined the term tipping point in the climate context, yet he won't go on the record to say that we passed the first tipping point or domino. Ward's comment to crossing the ice tipping point.
We don't know where it is. I mean, that's the thing about, unfortunately, climate effects and whole global processes. People who say that we're at a tipping point, I mean, first of all, that's just an absolutism. Nobody knows. And secondly, there's not one tipping point. There's going to be so many interlocked systems and climate systems that it is, again, a great big unknown at this point. Again, I'm following up my colleague. It's a terrible saw that we scientists say we need more research, but here, boy, we really need more research. Look, we've only been really looking in any scientific way at these problems for 50 years at most, and in many cases, the last 20 years. And as Paul pointed out, only observations of the current climate systems are very brand new things. I mean, even back in the 1800s, people first started thinking. The Gulf Stream itself wasn't discovered until the last couple of centuries. We are brand new at this game. And to say we're at the tipping point, we don't know where that point is. There's not a point anyway. It's a tipping line or a tipping plane or a tipping universe.
Yeah, if I were in Greenland, I would be worried.
Yeah.
There are many tipping points, and it's a job for mathematicians. This is nonlinear system dynamics. Some people actually know this math. And this is the kind of complex system where there are many tipping points. It's
Yes.
all about what Peter just called thermohaline currents. And what is a thermohaline current? It has to do with temperature and salinity driving whether you've got a current or not. What's the density of water? There are definite tipping points where the density of water changes as a function of saltiness and temperature. And if I lived in Greenland, I would be confused because you got two problems there in Greenland. There's the first tipping point. You got the melting of the ice of Greenland due to general warming, which causes fresh water to block the Gulf Stream. England might freeze over if that continues, but it won't continue because the ice will melt. And a lot of people are saying, hey, the ice is going to melt. We will lose this salinity effect. We'll stop having this bigger flow of fresh water, but there's a temperature effect also. And this is what confuses people. You got one effect in the short term based on fresh water. You've got another effect based on the temperature of the Arctic Ocean. And the data shows the temperature of the Arctic Ocean hitting a tipping point. The tipping point is about 0 degrees C for water of that saltiness. And that means I would be worried if I were living anywhere in the North Atlantic.
Well, everybody can worry about his own choice of topics today because we've just touched on a whole bunch of them and it's time's up. But I want to probably invite you guys back because there's more to be said on all of these subjects and related issues. So this is, I'm extremely grateful to you for the work you're doing and for the overview that you can produce for people to, anybody who's willing to let it sink in. That's what we need to do. Just put it out there some more. So thank you both and say goodbye now. Okay.
Thank you.
Appreciate it.
Yes,
Bye-bye.
thank you so much, Meta, and thank you for
Okay.
your service.
All right. Wonderful. Bye.
Bye.